Hello guys, we are going to talk about polynomials, linear factors, and zeros. We want to make sure that we understand that zero, x-intercept, and roots all come from a factor. Also, we want to be able to identify multiplicity and decide whether the graph goes through or touches. And when I say go through, I also mean cross, so I might use both of those words. And then we want to write a polynomial function if we were given zeros, okay? So let's talk about some really important words here. Multiplicity. Multiplicity is the number of times that its linear factor appears. So if I'm talking about multiplicity of a zero, so if my zero is 4 with multiplicity 2, I know that I'm going to have x minus 4 as a factor, and it was squared. So that's kind of what that means, okay? And again, I cannot stress this enough. Zeros, x-intercepts, solutions, and roots, they all mean the same thing, okay? Multiplicity is important because if we know something has odd multiplicity, we know that it goes through or crosses the x-intercept or the x-axis. And we know if it's even multiplicity, it's just going to touch the x-axis, okay? So touch versus cross. All right. If you have a factor, you can find the x value that makes that zero. That's called the zero, right? But if you have a zero, you can also go to the factor. So for instance, when I have a 0, -5, that really means that x was -5. And to find out the factor, I get 0 on one side. And so this is x plus 5 would have been 0. So there's the factor, okay? The thing you kind of have to watch out for is we aren't going to want to have fractions in our factors. So if I start out with x equals 1/2, I'm really going to want to multiply both sides by 2. And then I'll have 2x is equal to 1. And then when I subtract 1, my factor will end up to be 2x minus 1. So we really want to make sure that we don't have fractions in our factors, okay? So maybe write yourself a little note, no fractions in factors. Okay, cool. All right, so let's look at some graphs and see what we actually notice. Just because we were just talking about touching and crossing, right? This guy is going to cross, this guy is going to cross, and this guy is going to cross through the x-axis. And those are all zeros, right? So our zeros for this would be -4 and -2 and 1, and they're all going to be odd multiplicity because they cross, okay? So those are some things that you notice. We also notice that we have a turning point here and a turning point here. We notice that our end behavior, it goes down and then goes up, so we have opposite end behavior. So we know that our degree is odd. And because it starts going down and then goes up, that means that it has a positive leading coefficient. Okay? All right, which means there's a positive number in front of the term that tells you the degree. Okay, let's look at this one again. So this guy is crossing or going through, and this guy is touching. So when we're looking at this, our zeros are -2 and 5, and this one crosses, and this one touches. So this guy will be odd multiplicity, and this guy will be an even multiplicity, okay? And again, the graph goes down and then comes up, and so we know that this is going to be, it has opposite end behaviors. So that means it's going to be an odd degree. And because it goes down and then up, it's going to be a positive leading coefficient. Okay, also just like little side notes, we also can notice the y-intercept. So this is 0, 10. We can notice the y-intercept here. And so this is going to be 0, -8. So these are just points that you can notice, because if we were trying to match these with actual equations, we know that that point has to work. It has to make it true. Okay, let's look at this guy. We have this one. So our zeros are -1, and it touches, right? It touches, or so we are just going to know that that has an even multiplicity. And we know that this guy right here is 2, and that also touches. So we have even multiplicity on that factor. We know our end behaviors are going in the same direction. End behaviors, same direction. So that means that it has an even degree. Okay, and because they're going up, up, it means that the leading coefficient is positive. Okay, so those are some things. And again, we have that y-intercept if we wanted to look at it, and that guy is going to be 0, 4. Okay, so those are some things that we can notice from a graph, and it would help us match the graph to an equation. Okay, now what we're going to do is we're going to work backwards, right? So we're going to write that polynomial function in factored form, which means don't multiply it out. And we're also going to want to state the degree of the function, okay? Side note, multiplicity is going to be 1 unless it tells you. So in other words, this 5 doesn't have multiplicity after it, so it has multiplicity 1. So first what we're going to do is we're going to take each factor and each 0 and make a factor out of it. So remember, we did this by going x equals 5, x equals -2, x equals 1/2, especially with the ones that are fractions, because we don't want any fractions in our factors. So this one is going to be x minus 5 is equal to 0. So that means our function, because this has multiplicity 1, would have one of these, okay? Then we go to the next one, and we add 2. We have x plus 2 is equal to 0. So this guy has multiplicity 2, so x plus 2, because it has multiplicity 2, is going to have degree 2. And our last one is a fraction, so we will need to get rid of the fraction first. So we're going to have 2x is equal to 1, and we subtract the 1, and we get 2x minus 1 is equal to 0. And so that would be 2x minus 1, and because there's nothing after it, it's multiplicity 1 also. So let's talk degree. So if we wanted the degree of this, we're going to take 1 plus 2 plus 1, because inside they all have 1s. So I'm just basically having x times x times x, right? So this is going to be degree 4. Okay, let's check this guy out. Again, you can pause the video anytime that you want. So this 0 is going to give us the factor x plus 1, and it says multiplicity 3, so we're going to get that. This guy is going to give our factor x minus 2, and you can do it the slow way if you want, and it has multiplicity 1. And then this factor is going to give me x minus 7, or this 0 is going to give me x minus 7, and it's multiplicity 2. So our function would look like x plus 1 cubed, x minus 2, and x minus 7 squared. And when we talk about the degree, because all of those factors are linear, it's just going to be these exponents. So 3 plus 1 plus 2, so that is 7. Okay, cool. All right, so now what we're going to do is we're going to find the x-intercepts of the graph and decide whether it goes through. And when we say go through, it's the same as cross or touches, okay? So remember, when we go through, it's odd multiplicity, and when we touch, it's even multiplicity. So go through or cross will be odd. Okay, so our zero, this is going to have -2 as a 0 because -2 plus 2 is equal to 0. If you still don't know, you can go x plus 2 equals 0 and find out what's going to make that 0, and it's going to be -2. Okay, so our zeros it's going to be -2, and it has multiplicity 2, right? So, and then the next one that we have is going to be 5, and that has multiplicity 1. Okay, so what they're asking for is our x-intercepts. Now, zeros can be just written as numbers, but x-intercepts have to be written as points. So -2 will give me -2, 0 as an x-intercept, and it has multiplicity 2, so this is even, so it's going to touch. Then 5 has multiplicity 1, so we would have the x-intercept 5, 0, and it would cross or go through because it's odd. Not because the 5's odd, because the multiplicity is odd, okay? All right, so let's go through this one. So our zeros are going to be 4 with multiplicity 1. Let's go M1. And 1 with multiplicity 1. And -2 with multiplicity 3. Okay? So now we're going to talk x-intercepts. X-intercepts. We're going to have the 4 is going to be 4, 0, and it's multiplicity 1, so it's going to cross. The 1 is going to have x-intercept 1, 0. Remember, x-intercepts and y-intercepts have to be points, and the multiplicity is 1, so that's odd, so it'll cross. And then the 0, -2 is going to be the x-intercept -2, 0, and that has multiplicity 3, which is odd, so it will cross the x-axis. All right, let's look at our last one. Now here's something that I just want you to realize. If you just have x and it doesn't have anything with it, that 0 is just going to be 0. And in this case, it has multiplicity 3 because of the exponent. And this one is going to be -8, and it has multiplicity 1. Okay, so now we talk about x-intercepts. So we just talked about zeros. Zeros and x-intercepts are completely related. We just write x-intercepts as points. So 0, 0, because it has multiplicity 3, it's going to cross because that's odd. -8 would be -8, 0. And because multiplicity is 1 and it's odd, it's going to cross. Cool. All right, so I hope this helps you guys. And feel free to email me if you have any problems. Okay, take care.